Okay, today we shall have a look at a very important concept in neural networks, that is linear separability. For two-dimensional inputs, if there exists a line that separates all the samples of one class from the other class, then such a classification problem is called linearly separable. So we shall take an example and see. Now in this particular diagram, this is a particular two-dimensional inputs are shown. The inputs are x1 and x2, and there are two, in both these figures there are two classes, patterns belonging to two classes. We have got blue dots which are there and orange dots. So blue dots belong to one particular class and orange dots belong to another. Now if at all it is possible to separate these patterns from these two classes by just drawing a simple line, then we call this as linearly separable classification problem. So can I draw a line in this figure 1? Can I draw a line using a single line? Can I separate it? Yes, both the patterns can be separated by drawing a single line. So this particular classification problem is linearly separable. So by drawing a line, it is possible to separate the patterns from two classes. So this problem is called as linearly separable problem. But if at all here it is not possible for me to draw a line, if at all I draw a line, what will happen is that some patterns of class 1 are still lying on the other side, and some patterns of class 2 are lying on the other side. So it is not possible to draw a line and separate. In this case it is called as linearly not separable. So linearly non-separable, or it's not possible to separate the two classes by drawing a single line. So if at all I can draw a single line as I have shown here, then it is possible to have a perceptron design, and this perceptron can be derived from the equation of the line. So whenever I draw a line, it will be having some equation in terms of x1 and x2, and this, using the coefficients of this particular line, I can derive the perceptron. But otherwise it is in this case it is not possible to have one particular perceptron which will be separating the two classes. So here I require only a single perceptron which will be doing this classification problem. So if at all a single perceptron can achieve the task of classifying the patterns from two different classes, then it is called as linearly separable problem. Now, if at all one example I shall take an example of an OR gate. So if at all you consider an OR gate, what we can see is that the truth table is shown. When the input is 0, 0, the output is 0, and otherwise the output is 1. So this I consider as one particular class, say class 2, and whatever I have shown with 0, this pattern belongs to class 1. So two different outputs, 0 is one class and output 1 is another class. So at this particular point, that 0, 0 point, I will be getting this particular pattern. But at the next pattern, that is 1, 0, 0, 1 and 1, 1, these points I will be having the second pattern, that is which belongs to class 2. So now these are patterns belonging to different classes. Now is it possible to draw a single line such that these patterns can be separated? Yes, I can draw a single line like this which will separate these patterns. So this particular line, I will name it as say O. And what is the equation of this line? Say into intercept form, I get equation of this line is x1. Say this point is say 0.3, 0 and this point here is 0, 0.3. So I will get x1 upon 0.3 plus x2 upon 0.3 is equal to 1. So x1 plus x2 minus 0.3 is equal to 0. So this is the equation which will be used. Now class 1, class 2, I take the direction as positive. So I can design a neural network with x1 input, x2 and bias 1 and weight as 1, 1 and minus 3, minus 0.3. So this perceptron I can use to perform the OR problem. So OR classification problem can be solved by using a single neuron. So I am simply using a one neuron here in order to solve this classification problem. So it is a linearly separable problem. Is that clear? Now we move on to linear non-separability. Okay, next is linear non-separability. If no straight line can possibly separate the samples belonging to two classes, then it is not possible for a single perceptron to achieve the classification task, and the samples are called as not linearly separable. So we shall take an example. The first example we take is the XOR problem. So in the XOR problem, if at all you see, okay, if at all you see here, what happens is that the truth table is shown, and you can see that when it is 0, 0 and 1, 1, the pattern belongs to class 1, and that is I will denote it as 0 here, and whenever the inputs are 0, 1 and 1, 0, the pattern belongs to class 2, which is denoted as X. So now is it possible by simply drawing a line to separate these patterns? If at all I draw a line somewhat like this, then it is not classifying. So this one particular point is still misclassified. So it is not possible to, by simply drawing a single line to separate this particular problem, we may require two lines. With a single line, it is not possible. So by just using a single line means a single perceptron. So by using a single perceptron, if at all it is not possible to separate the two classes, then it is called as not linearly separable or linearly non-separable problem. So we move on to the next example. These are some more examples. This is a peninsula problem. So peninsula means you can see that the pattern of one particular class, these are all patterns of one particular class, they are encroaching into another class. So here also it is not possible to separate it. We may need more than one lines or something like this to separate it. So this is not a line. So it is a combination of some lines. So by simply using a line, it is not possible. So it is a non-linear separable problem. Again, we can move on to the next one. That is an island problem. So here you can see that these patterns, so you can see here these particular patterns from a particular class are inside or are surrounded by the patterns of another class. So by using a single line, maybe you will have to use some 4 lines like this in order to separate these patterns. So you will have to use 4 lines like this to separate this particular problem. So this is again a problem which is non-separable by using a line. Now this is, we have seen only in 2 planes, that is x1, x2 plane, that is a 2-dimensional plane. So 2-dimensional plane problem should be, if at all it is solved by using a 1-dimensional line. See, line is 1-dimensional, right? Then it is called as linearly separable. So what are the problems in 3-dimensional? So 3-dimensional problems should be are called as linearly separable if at all they can be separated by a plane. So 2-dimensional problems, supposing I draw x1 and x2, then these problems if at all these are some patterns in one class and some other patterns in the other class, they should be solved by using a line which separates, and line is one dimensional. Now if at all I have a three-dimensional problems, so three-dimensional problem, it is very difficult to draw the problems, so somewhat like this cube we can draw, and if at all, now three-dimensional problems, if at all I want to solve, somewhat like this cube will be drawn, and there are some points, and three-dimensional XOR gate will be like a three-dimensional problem, three-input XOR gate. So there are some patterns here and here and here and something like this, and there are some other patterns at this particular corner, this particular corner. So if at all you want to separate these particular patterns, then what I need is that I will be needing a plane. So there should be a plane which cuts off this three-dimensional figure such that the patterns from one particular class are on one side and other particular class are on other side, then it is called as linearly separable. So for three-dimensional inputs to be separated, a plane is required, and plane is nothing but two-dimensional figure. And if at all you go beyond this, that is beyond this meaning it will be x1, x2, x3, x4, x5, etc. So a neural network can have any number of inputs. So to separate the classes in n dimensions, then we require n minus one dimensional hyperplane. So line is a two-dimensional figure. Line is one dimension. Plane is two dimension, and anything more than that, beyond that, is called as a hyperplane. So a hyperplane is used to separate the three-dimensional, four-dimensional inputs, five-dimensional inputs, etc. So in general, what linear separability is used for? Linear separability is used to check if you can separate points in n-dimensional space using only n minus 1 dimensions. So what does it mean? For 2D space, I should only be able to use one dimension. N minus 1 is one dimension. And one dimension meaning it is a line. For 3D space, I should be able to use only two dimensions, that is a plane. So this is what is the meaning of linear separability, and it is a very important concept. Now we shall just solve this simple problem. Consider 2D samples belonging to two classes. So 0, 0, 0, 1, 1, 0 and minus 1. Minus 1 these four patterns belong to class 1. And 2.1, 0, 0, minus 2.5, 1.6, minus 1.6 belong to class 2. We have to check if these patterns are linearly separable. If they are linearly separable, we have to design a perceptron that separates their patterns from both the classes. Is that clear? So now we can see here I have drawn the 2D space, I have got the 2D space here, and I shall take these points and mark these points. The first point, so these class 1 points I will indicate as a 0, and class 2 points I shall indicate as a cross. Okay. So 0, 0. Where is 0, 0? First 0, 0 is here. So I shall draw this point 0, 0. Then we have 0, so 0, 1 is this particular point here. Next point is 1, 0. It is this particular point here. And next is minus 1, 1. This is minus 1, 1. Now we go to the second class points which are indicated as x. So which are those points? 2.1, 0. So where is 2.1, 0? Here. Somewhere here I am marking it as 2.1, 0. Next is 0, minus 2.5. So 0, minus 2.5 is somewhere here. And the next point is 1.6, minus 1.6. So So around 1.6 comma minus 1.6, somewhere here will be the point. So all these points are plotted. Now, is this going to be, can I draw, are these points linearly separable? Looking at this, I can say yes, these points are linearly separable. So, if yes, I have to draw a line, and I shall take one line which says that points are linearly separable. So, I shall draw this line somewhat like this. So, this line will be separating the points, okay, this line will be separating the points. So now, with the help of the equation of this line, I can design the perceptron. So what will be the equation? I will be writing the equation as x1 upon, say this point I take it as 1.5 comma 0. And this point will be 0 comma minus 1.5. So the equation will be x1 upon 1.5 plus x2 upon minus 1.5 is equal to 1. So if at all you solve this further, I will be getting the perceptron equation as x1 minus x2 is equal to 1.5, which is nothing but x1 minus x2 minus 1.5 is equal to 0. So this is the equation for the perceptron. So we can draw a network with this particular perceptron. I shall draw it here itself. 3 inputs, 1 neuron. X1 is the first unit input, second unit is X2, third unit is a bias. The weight of this is 1, minus 1, and the weight of this is minus 1.5. So this is perceptron and this is the output. So this perceptron, it is said, design a perceptron that separates the patterns from both the classes. So this is the perceptron which will be separating the patterns from both the classes. Is that clear?